Good everyone. This is Praveen Kumar, lecturer, Government Polytechnic Kardi, welcoming you to the another session of measuring instruments. That is Unit 1 of third sem Mechanical Diploma. Okay. So in the last session, we had learned about different topics. That is screw thread metrology, pitch diameter, thread gauge micrometer, and bench micrometer. Okay. I'll just have a review on those, a revision on those particular topic. So we know what is screw thread metrology. Okay. So screw thread metrology is something which deals with the measurements of the threads. To understand what are the measurements, we can take from screw threads. We should know about the terms, elements of this. So screw thread metrology deals with those particular terms. So you would have heard about screw thread, external threads, internal threads, and all other terms which are related to the screw thread metrology. Okay. And next we come on to the pitch diameter. So what we know, pitch diameter, we heard about what is pitch diameter. So pitch diameter is something, it is a diameter of an imaginary cylinder which passes through a thread profile at such points as to make the width of the thread and width of the spaces between the threads are equal. Okay. And also we learned about thread gauge micrometer. So let you know what is, I'll just define what is a thread gauge micrometer. So thread gauge micrometer is a device used to measure the pitch diameter of a screw thread. It is just like an ordinary micrometer and it has pointed spindle and a double V handle. Both are correctly shaped to contact the screw thread. Okay. And also we learned about what is a bench micrometer. So bench micrometer is again one more type of the micrometer which is used for calculating the or measuring the screw thread, external major diameter of the screw. Okay. So this is all we had in the previous session. Okay. Now we will move on to the what are the multiple choice questions we had in the last session. Okay. I will just read out the questions and also we can have the answers for the same. Okay. So the first question of the last session was a pitch diameter of a thread is. So there were four options given, that is nominal diameter of the thread, imaginary diameter in between the major diameter and the minor diameter of the thread, and minimum diameter of the thread and maximum diameter of the thread. So out of all these four options, the correct answer was imaginary diameter in between the major diameter and minor diameter of the thread. Okay. And next we will move on to the next question. That is, a thread gauge micrometer is used to measure dash diameter of the thread. Okay. The correct answer is the effective diameter of the thread. That is, a thread gauge micrometer is used to measure the effective diameter of the thread. That is option number 4. Okay. And the next question was, which is used to measure the major diameter of an external thread. Option was the number 1, that is bench micrometer. So bench micrometer is one micrometer which is used to measure the major diameter of an external thread. So all these things we had actually learned in the session, and all these questions were given at the end of the session. So it was asked to you guys to learn about it. Hope you have answered correctly. Okay. Anyways, I will be revising the fourth one as well. So all the questions as well. Okay. The fourth question was the indicator that enables the application of a pressure already decided upon the screw thread in a bench micrometer is called as. So the correct answer is a fiducial indicator. Okay. So next the question was, from the following which one is not a method to find the effective thread meter? Okay. So thread diameter. The option was the V-piece method. So other three methods which were thread micrometer, 2-wire methods and 3-wire methods, these are all these methods are used to find the effective thread diameter, but the V-piece method is not used to find the effective thread diameter. Right? And the question number 6 was, what is the name of a screw thread which is formed on a core? The correct answer is tapered screw thread. Okay. And the 7th question was, what type of the thread which is formed on a female screw gauge? The correct answer is internal thread. Okay. And the 8th question was, it was a true or false question, which is flanks in the threads connect to the crest and the roots. Is it correct or is it true or false? The answer is it is true. Okay. And the 9th question is, if a nut when turned in clockwise direction screws on a bolt, the thread is left-handed. Is it true or false? The answer is it is false. That is option B. Okay. And the last question was, the distance through which a screw thread advances axially in one turn is called as, it is lead of thread. Okay, so that is the correct answer. Lead of thread is the distance through which a screw thread advances axially in one turn, right? So these were all the answers for the previous session. Hope you all have answered correctly. I congratulate all the people who have answered it correctly at one shot. Okay, so thank you for all answering correctly, and we'll move on to this particular session. So we'll look into the details. What are we going to learn in this particular session? So in this particular session, we'll be learning about angle measurements, bevel protractor, sine bars, and as well as some of the multiple choice questions related to this particular session. Anyways, after the end of this session, I will be giving you the answers of this particular session since I will not be handling the next sessions. Okay, so we'll move on to the first particular topic, which is called as angle measurements. Okay, so what is an angle measurements? Angle measurement. The angle is defined as opening between two lines which meet at a point. For engineering purpose, the angular units are defined in sexagesimal system, that is degrees, minutes or seconds, right? And the angular measurement while measuring of jigs, dies, etc. Okay, you can see the figure, you will know better, right? So we'll move to the next slide. The different instruments or devices which are used for angular measurements are simple protractor, universal bevel protractor, sine bar, sine center, angle gauge, collineometer, autocollineometer, and the taper gauge. So these are all different instruments which are used for measuring the angular measurements, right? So we will look into detail about the universal bevel protractor. So what is a bevel protractor, right? I'll let you know what is a bevel protractor. It is a simple device used to accurately measure the angle between two surfaces of a component is the bevel protractor. Okay, and bevel protractor measures the angle in degrees and minutes. We can look into the figures which shows you different parts of the bevel protractor. That is, you have a stock or base plate, we can call it as base plate, you have vernier scale, you have acute angle attachment, you have circular plates, you have adjustable blade, you have blade clamp, you have groove, you have clamping knob. Also in the figure number 2 you can also see the other parts of the bevel protractor. Okay, so now we'll move on to the different components of bevel protractor. You can have a look into the figure, it will give you a better picture. Okay, so you have figure number 2 here, right, which is showing you what is so different parts of the bevel protractor, right? So now we'll move on to the components of bevel protractor. You can see the construction part of it. Okay, I'll be just letting you know, right? So you have different parts, that is body. So what is body? Body, it is designed in such a way that its back is flat and there are no projections behind its back, so that the bevel protractor can be placed on its back on a surface plate perfectly, right? And another part is called as component is called as stock. The working edge of the stock is about 90 mm in length and 7 mm thick. And you have blade. So blade is something which can be moved along the turret throughout its length. It is about 150 mm or 300 mm long, 13 mm wide and 2 mm thick, and hence beveled at an angle of 45 degrees and 60 degrees. And you have one more component which is called as acute angle attachment. The instrument is provided with an acute angle attachment which is used for measuring the smaller angles. So let us discuss how is the working of a bevel protractor, right? We will have a session on working of bevel protractor. Okay, so working of a bevel protractor. See, it has a base plate attached to the main body, which is a circular disc and engraved into 360 degrees. The adjustable sliding blade is attached to the main body with a circular plate containing vernier scale. Right? The sliding blade can rotate freely about the center of the main scale and can be locked in a desired position. The back plate is flat at its bottom, which makes contact with one of the surfaces to be measured, while the rotatable blade make contact with the other surface and surface under measurement, right? In this position, the main scale and the vernier scale readings are taken. So this is how the measurement is taken in by using a bevel protractor. Hope all of you understood the working of a bevel protractor. So let us look into some of the uses of the bevel protractor, like applications of bevel protractor. So bevel protractor is used for checking a V block. You can look into the figure wherein a bevel protractor is placed on a V block to measure, right? And for measuring an acute angle for application number 2. And for application number 3, it is used for checking the inside beveled face of a ground surface, right? So these are all some of the applications of a bevel protractor. Hope you all have understood about the bevel protractor. Anyways, I do have a video which shows you some parts, a clear description of the parts of the bevel protractor. So you can watch the video. Okay, so all of you have learned about the bevel protractor, I suppose. Okay, you have watched the video. I think you have got more clear picture on how a bevel protractor is used and what are its different parts. And okay, so next we will move on to the next topic, that is sine bar. Okay, so as you are visualizing the picture of a sine bar which shows different parts of a sine bar. Okay, and I'll let you know the construction part of the sine bar. So sine bar is used to measure angles more precisely than a bevel protractor for or for locating any work to a given angle within a closed limits. It is generally used in conjunction with slip gauges. A sine bar consists of two hardened and ground steel bar which are stepped at the ends. A roller is fastened and each step with a screw. These rollers should touch both faces of the step. A sine bar is specified by the distance between the centers of two rollers. The distance between the axes of the two cylinders will be 100, 200 and 300 mm. So this is about sine bar. So here you are having a picture or figure of a sine bar. Okay. If a sine bar is to be accurate, then the following properties must exist. That is, the distance between the centers must be precisely known, right? And the axes of the rollers must be parallel to each other. And the third one is the upper surface of the sine bar must be flat and parallel. And the fourth point is the rollers must be of identical diameters and round to within a close tolerance, right? And now we look in how exactly the measurement is done by using a sine bar. For measuring angle of a given specimen, the sine bar must be made as follows. You have two figures here. One is one on a roller placed on slip gauges, and the second one is both the rollers are placed on the slip gauges. So you are having a picture, a figure which is showing in detail, right? And next we have, I'll let you know what are the different conditions. The work having tapered top and flat base is placed on the surface plate. Second one of the rollers is placed on the surface plate while the other roller is made to rest on the slip gauges of height h in such a way that the tip of the workpiece coincides with the sine bar. Third one is, let the sine bar is set at an angle of theta. Sin theta is equal to h by L. And fourth, in order to obtain the better results, both the rollers of the sine bar are placed on the slip gauges of height h1 and h2. So the angle will be measured is equal to sin theta is equal to h1 minus h2 divided by L. So this is how angle is measured by using the sine bar. Hope all have learned about the sine bar and working of sine bar. And now let us look into some of the uses of, or we can also say applications of sine bar, right? So sine bar is used for checking the flatness of a surface, and also sine bar is used for locating a work in a required angle. And third one, sine bar is used for checking angle of a taper key. The last one, sine bar is used for checking bevel gears, right? So you all have learned about different uses of our applications of sine bar. Now we will move on to some of the multiple choice questions which I had informed you that I will be asking at the end of the session, right? So we have few multiple choice questions in which in this particular session I have even given the answers to those particular questions. Okay, so since I will not be handling the further sessions. Okay, so the first question is the device which is used to measure the angle between the two surfaces of a component is. That is, you have four options. That is universal bevel protractor, ring gauge, plug gauge, and fourth one is none of the above. The answer is option number 1. That is universal bevel protractor. Right? The universal bevel protractor is a device which is used to measure the angle between two surfaces of a component. Right? Next we will move on to the second question. So which of the following is not used in making of sine bars? There are four options, that is high carbon, high chromium and corrosion resistant steel and aluminium. So answer is number 4, that is aluminium. Aluminium is not used in making of sine bars. Next we will move on to the third question, that is where will be the vernier scale is present in a bevel protractor? Is it a base protractor or a circular plate or adjustable plate or main body? The correct answer is option number 2, that is circular plate. Okay. Next is the fourth question. So fourth question is what is the range of a bevel protractor. Is it 0 to 90 degrees? Is it 0 to 180 degrees? Is it 0 to 360 degrees? Or is it 90 to 270 degrees? The correct answer is option number 3, that is 0 to 360 degrees, right? And question number 5 is, the term rigging is associated with, is it slip gauges, or is it rack and pinion, or is it shanks and collets of a drill, or is it angular measuring instruments? The correct answer is the first one, that is slip gauges. Next, we will move to the last question, that is, which aspect is used to specify a sign bar? The answers are option number 1, it is sign of the rollers. Is it the center distance between the two rollers, or is it the distance between the rollers and the upper surface, or is it its total length? The correct answer is option number 2, that is the center distance between the two rollers, right? So these were all different questions which were asked in this particular session. Hope all of you have learned about the sign bars, and we have learned about bevel protractors, and we have learned about angle measurements. Okay, so this completes this particular session. I thank you all for attending this particular session. Thank you.